A good day to everyone who is watching. My name is Kasule Moses, and in our lesson 9 of matrices today we are going to talk about the inverse of a 2 by 2 matrix. So suppose I'm having my matrix A as A, B, and C. The inverse of A, first of all, is denoted as like that. If I don't write the word inverse of A, we can write that to mean the inverse of A. So it is given by 1 out of the determinant of matrix A, then times the adjoint of A. In some books, this word, the adjoint, they call it adjunct. They call it that one. So in some books, if you find that, means the same thing as the adjoint. Now, from our matrix there, I know that I have not talked about the adjoint. So adjoint of A is also a matrix, but the way we get it is we interchange values in the leading diagonal or elements in the leading diagonal. That is, the D takes up the place of A and the A takes up the place of D. Then those in the minor diagonal, they are going to change signs. So from our matrix A there, though the B and the C were positive, and now they are going to become negatives. Then in the previous lesson, we learned how to get the determinant of any matrix. So that is A times D, then minus the B times the C. That was the determinant of a 2 by 2 matrix. So when I substitute in that formula there, that is going to be 1 all over A times D minus B times C, then times the D minus the B minus the C, then the A. Now, this value here becomes a scalar. We talked about scalars multiplying matrices. So this scalar will be multiplying whatever element is inside there. That is, when I multiply, that is going to be D all over the AD minus BC, then negative C all over AD minus BC, then negative B all over AD minus BC, then A all over AD minus BC. So let us go into more examples. Example 1, find the inverse of matrix A, which is 2, 2, 2, and 3. So we need two things to find the inverse. That is the determinant and then the adjoint. So determinant of matrix A, elements in the leading diagonal, their product, minus the product of the elements in the minor diagonal. So that one there is 6 minus a 4, we get a 2. Then the adjoint of A, we said we are going to interchange those in the leading diagonal, that is a 3 and that is a 2. Those in the minor diagonal, they change signs like that. Then finally the inverse, 1 out of the determinant times the adjoint. So when I substitute 1 out of the determinant, 2 into the 3, negative 2, negative 2, 2, then this scalar is going to multiply whichever element is inside there. So that is 3 all over 2. There, that is negative 1. That one is negative 1. A half times that, we get positive 1. So that is the inverse of matrix A. Example 2, given that matrix B is 1, 2, 4, 11, find the inverse of matrix B. So our inverse is 1 out of the determinant of matrix B times the adjoint of B, getting the determinant of B elements in the leading diagonal, their product, minus the product of elements in the minor diagonal. So that one there is 11, then minus that one there is 8, and we get the determinant as a 3. Then the adjoint, we interchange those in the leading diagonal, we change the signs, those in the minor diagonal. Then finally, the inverse, 1 out of 3 times 11, negative 2, negative 4, 1, which is equivalent to 11 all over 3. This is negative 2 all over 3, negative 4 all over 3, then 1 all over 3. As simple as that. Now we have to note some things, is that when we are having matrix A times its inverse, that one gives us an identity matrix, which is the same as the inverse times the A. Then our matrix, if we have the inverse of an inverse, that takes us back to the original matrix. Then if I'm having A times B inverse outside the bracket, then this is the way it is. That is, it's the same thing as getting the inverse of B times the inverse of A. Now, note 4, if I'm having my matrix A times B is equivalent to C, and I need to get my matrix B, what I do, I'm going to use note A. So I multiply the inverse on both sides of the equation. So that is A inverse times the C. So when I multiply these two from note 1, I get the identity matrix, which is A inverse times matrix C. Then when we are dealing with the identity matrix, we say that when we multiply the identity matrix times any matrix, we get that any matrix. So suppose I'm given these two, I'm given matrix C and then matrix A, that I need matrix B, I can use this one here to get my matrix B. Example 3, we did it some time back when we were looking at the matrix multiplication, or the multiplication of matrices and then equal matrices. In that lesson there, we did example 3. So we are going to redo it again using another concept, and that concept is coming from our note 4. So I need to get my matrix N. Then I've been given matrix M and the product of those two as 12, 0, 0, 12. So to get my matrix N, I'm going to multiply the M inverse times that product there, the product there. So I need to first of all, determine my inverse of matrix M. Determinant of M is equivalent to 2 times 3 minus 2 times 1, and this is 6 minus 2, which is 4. Then the adjoint of M is equivalent to 3, 2, negative 1, negative 2. Then to get the inverse of M, this is 1 out of 4 times the adjoint, which gives me 3 all over 4 minus 1 all over 4. Then this is 1 all over 2, and then 1 all over 2. So I'm going to get this inverse, and I multiply it with that matrix there to get my matrix N. So matrix N is going to be equivalent to 3 all over 4 minus 1 all over 4 minus 1 all over 2, positive 1 all over 2, then times 12, 0, 0, 12, row by column, and we add. So when I multiply there, I'm having a 9 plus a 0. Then row by column, there I'm having a 0. That is going to be negative 3. Row by column, and I add. That is going to be negative 6 plus 0, negative 6. Then row by column, that is going to be 0 plus positive 6. So I get my matrix N as simple as that. Remember, in the other lesson where we did example 3, we had to solve simultaneous equations. We had to let the N to be equal to some matrix ABC, and then we solved until when we had 2 simultaneous equations that we solved to get the elements 9, negative 3, negative 6, and the 6. Example 4, you've been told to find the matrix A given its inverse. So there we are going to use our note. Our note 2 is that we are going to find again the inverse of that inverse to get the original matrix A. So the determinant of the A inverse, that is negative 1 times negative 2, that is negative 1 times negative 1.5. So this one here, I get positive 2 minus 1.5 to get the answer as positive 0.5. Now to get the adjoint of A inverse, we interchange elements in the leading diagonal, we change the signs, elements in the minor diagonal, which is that. Then to get the inverse of A, that is 1 out of the determinant, that is 0. Then times the adjoint, negative 2, 1, 1.5, then the negative 1. Now my 1 all over the 0.5, when you simplify 1 out of a half, this one will give you a 2. So this is a 2 into a negative 2, 1, 1.5, negative 1. Then when I multiply, so this is I get negative 4, positive 2, a 3. When I multiply, this is I get a negative 2. So this one here, I get my original matrix A. So try out those numbers, and then you'll be giving me a feedback.